Okay, section 6.6, systems of inequalities. Last lesson we did stuff like this where we might have y is greater than or equal to. We shaded a line because it's got the underline. If after we graph, that would be a solid line, and if it's greater, we shade it above, and that would be the solution. Now, what we're going to add to this is we're going to add a second line, and let's say it's y is less than, and we shade a second line, and if this one's less, we would shade below the red line. But then what we have to determine which area gets shaded twice. The area, that's what the lesson is about, okay? So if we look here, after I've drawn it, I have 1, 2, 3, 4 areas that are made by the X, basically. And sorry, I did mess one thing up. This one should have been a dashed line because I said y is less than. But which area got shaded twice? 1, 2, 3, or 4? 1. And that's what we're looking at because it got shaded both with the black and the red. Okay? So, and that is the area that is called the solution. Now, one of the things that you have to do, we got 4 problems in this lesson that we're going to look at. At this point, you should be able to get y by itself. The first one has y by itself. It says y is greater than or equal to 2x minus 1. Okay, so you don't have to do anything. Y is already alone. You have to be able to identify m and b. M is 2 over 1, b is negative 1. So you should be able to graph this. You have your packet? Okay, so we go down 1, and we put a dot. From there, we're going to go up 2, right 1, and we can continue to do that. Now, as you read, this would read, y is greater than, so we would shade above. Okay, but it's y is greater than or equal to, so first we need a solid line, and then we would shade above, but what I'm going to ask you to do is shade lightly. So I'm going to indicate shading lightly just by kind of putting some dots here. Anything above this line would be the solution to that one. That's what we did last week. But now we need a second equation. But the problem, the second equation doesn't have y by itself. So we need to get rid of something. We need to get rid of the x because it's on the same side as y. So I'm going to subtract x from each side. And we get y is less than negative x plus 2. All right, so now we have m is negative 1 over 1, b is 2. b is 2. We go down 1, right 1, down 1, right 1, down 1, right 1. This one will be a dashed line. And as we read this one, it's y is less than. Okay? Y is less than. So we would shade underneath. Now, ultimately, what we want is only one area. When you draw these, you get this X. And there are 4 areas, but we want the area that's shaded twice. So, if we go with the same numbers, 1, 2, 3, 4, which area got shaded twice? 1, 2, 3, or 4? 1. So that's the area that we really want to shade, indicating that those are where the answers would be. This area we wouldn't have answers, this area we wouldn't, this area we definitely don't have answers. So you can, at that point, if you want, you can erase the other areas and just indicate that that's the only area that is containing the solutions. Okay, so on the next one, again, it can't be where you're unable to just do this problem. subtract x, you should be able to get y by itself. Take the other equation and get y by itself right now. So you got to do one step to get that one by itself. Now, a lot of students might have put 7x. The 4 doesn't have an x on it. You can't put them together, right? So that one's 3x plus 4. Now, how do we graph these? Again, this is -1. We put it over +1. But you start with b. We go up 5. We put a dot. From there, we go down 1, right 1, down 1, right 1. And this one will be a solid line. Y is greater, so we shade above the line. Now, some students do it without putting the dots on or whatever. That's fine. Remember, what we're really going to look for most of the time is an X. And we're looking for one area. Right now, I know the area can't be this one or this one because it's above, but it could be this one or this one. Okay? Now the second line. We go up 4, we put a dot. Then we go up 3 over 1. This one will be a solid line. It says y is less. So we're going to shade underneath the blue line here. 1, 2, 3, or 4 of the options after the first line, it could have only been 2 or 3. But what's the area that got shaded twice? 3. Okay? So this area is the area you really want to shade in. If you're able to do it without shading the other areas, that's good. Okay? How many right now think they'd be able to do that? Okay? 1 so far. I'm betting there's more. All right? But, so 1. It's Monday. I understand. Okay. All right, next one. Y is greater than 3. Now this one, y is greater than 3. That would be a dotted line going across 3 on y. Now we would shade above. So in shading above, it's somewhere in that area. It's got to be above the blue line. An x equal line at -4. It's a solid line because it's got the or equal to. And if x is less, which way should we go? Left or right? Left, so we shade on this side. So what you should come up with is the top left area got shaded twice. Again, if you can do that without putting the dots on, great. Okay? And you might be like, well, how would I have done that? If you had done that one, where you graphed this and you kept track that this area is where you would shade, one of the two, and then this line, and you're shading to the left, you would come up with the idea that it's over there without having to shade. You just got to keep track in your head. And I don't need you to. I need you to be able to figure out which area gets shaded as the final solution. All right, so this one, we graph. Y is greater than 3x minus 2. We go down 2, we put a dot. Up 3 over 1, up 3 over 1. This one would be a dashed line, and we're going to shade above. Now the next one. I'm going to add x to each side. Two y is less than x plus 6. We put a 1 on here. this 1/2 x plus 3. Okay, so we graph this one. We go up 3, we put a dot. Up 1 over 2. We again have a solid line. Or in this one, we have a solid line. Sorry, the other one was dashed. And we're going to shade below. The area that gets shaded twice is this little area here. Now remember, it's actually a pretty big area because it continues to go down into here off the graph. Okay. Now we're going to look. We have a worksheet. I'm going to do number 3 quickly with you while we're still recording. Always a worksheet.
Is this the worksheet?
That's it. All right. So number 3 on this worksheet. Y is greater than negative x minus 3. So we'll start by graphing that one. Remember that negative x would be negative 1 over 1. So we start first with b. On your graph, and you have a graph on the worksheet, you're going to go down 3, put a dot. From there, you're going to go down 1, right 1. Continue to go down 1, right 1. Will this be a dashed or solid line? Dashed. And then according to this, we would shade above or below? Above. So remember, we're above the line. Now I'm going to do this one without the dots, but if you put dots on there or whatever, or shade it lightly, great. Second equation on number 3 is y is less than negative x plus 5. So we go up 5, we put a dot. Then we go down 1 over 1, down 1 over 1. And this one is also a dashed line. Now remember, we shaded above the blue line, but this one tells us we need to shade above or below. Below. Now there's only 3 areas. There's area 1, area 2, area 3. Which area would have gotten shaded twice? The middle. So this one, the answer that would have gotten shaded twice, we would have shaded above the blue and below the green. That would have been shaded twice. So anything in between the parallel lines would be our solution.